We're going to look at Unit 6, Solving Polynomial Equations. It is our last unit of this course, so be excited. Okay, it's only 5 lessons long, and hopefully nothing is super new to you. It's just kind of a recap and getting you set for those university or college courses you might be taking with this math. Okay, so lesson 1 is going to be simplifying polynomial expressions. This is hopefully not new to you. It is using like distributive property as your number one thing to help you solve problems today. Okay, so remember, here's your key idea. You can determine the product of a monomial and a polynomial by using the distributive property to expand it. So the key there, again, your distributive property. Remember that that means whatever's out front, this is a monomial here because it's one term, has to be multiplied into everything in the brackets. Okay, and remember that you're multiplying, so 2x times 3x squared, that's denoted by those brackets, and then you're going to add, because there's an addition sign here, 2x times 5. When you do that, remember you are multiplying, so 2 times 3 is 6, x times x squared is x cubed. Remember that that is from your unit 4, x times x squared. Remember that you are adding, like that's like x to the 1. So you add, you have a common base here, you add your exponents, and then you get 1 plus 2, which is 3. So that's how you get x cubed there. Okay, 2 times 5 is 10, and then you have an x there, so you just leave it as an x. Okay, so we're going to practice that a little bit throughout this lesson. So here's an example of a word problem that you're going to have to end up using distributive property. So Parm is an artist who works in metal and ceramics. He is building a sculpture in the shape of a large trapezoid. So you can see the trapezoid there. The sculpture's proportions are shown on the diagram. To order materials, he needs to determine the trapezoid's area. Okay, so I have posted a formula sheet on Google Classroom that will help you with knowing different areas of shapes if you don't remember. The area for a trapezoid is half of the h, which is the height, and then times a plus b. So when you're labeling this, your height, obviously, of your trapezoid is going to be the thing that is perpendicular 90 degrees, right, in your trapezoid. A and B do not matter. So let's just label this one A and this one B, but you could label A here and AB here. Doesn't matter, okay? Just choose what you want to for that. So you're going to go a half, and then your height, which is x, and then you're going to go A plus B. So A is x, and then x plus 4. X plus 4. Okay, I put double brackets around it. Doesn't really need that because you're just adding, but in case you ever had a negative value here, like negative x, and it would become subtraction, right? So keep the x first. Let's simplify in the bracket. So x plus x is 2x plus 4. Okay, now you're going to multiply this term, half x, into the bracket. So you're going to multiply it into the 2x and into the 4. So you're going to get a half x times 2x plus a half x times 4. Okay, so here you're going to get x times x, which is x squared, and then what's a half times 2? It's just 1. Okay, plus just a regular x there because you don't have any other x's, but what's a half times 4? Which is 2. So your final answer is going to be 1x squared plus 2x. And then there are no units here, so you would say therefore the trapezoid's area is x squared plus 2x. And it doesn't have, kind of silly, it doesn't have units, but usually you'd say like meter squared, or feet squared, or whatever it is, okay, for the metal and ceramic that he's using. Okay, so again, just coming up with the formula, you're just substituting in given values, and then you are using distributive property. Okay, we'll go into another example. I want you to complete and verify this equation. So I want you to figure out what this black box is to get the 8x cubed minus 20x. Okay, so there is a couple of ways that you could do this. You could just do it simply by looking at this and say, okay, what times 2 gives me 8? Well, 4, well, does 4 times negative 5 give me negative 20? Yes. And then what times x squared gives me x cubed? Well, x. And then does negative 5 times 4x give me negative 20x? Yes. So that is simply by just like looking at the equation. But I will give you another way of doing this. So let's look at the right side of the equation. You're going to have 8x cubed minus 20x. And if you notice there, you can actually common factor. So remember with common factoring, I know, bringing you back, I know a lot of you don't like factoring, but so common factoring, you're looking for the biggest number that comes out of both the 8 and the 20, which if you look at factors, so you have 1, 2, 4, and 8. Those are your factors of 8. Okay, and then look at your factors of 20. So you're going to get 1, 2, 4, 5, and 10, and then 20. Okay, so when you're doing that, you're looking for the largest common one, which is 4. Right? There's no 8 and 20, and then there's no 5, 10, and 20 in the factors of 8. Okay, so 4 becomes your common factor, so you can put it in the box if you want. And then what is the common factor of x cubed and x? Well, the largest one we can pull out is x. Okay, so you can take one x out. You can't take two x's out because you can't take 2 out of just a single x, right? That's an x1. Okay, so now when you're doing this, you are looking to fill in your brackets because you have your common factor. Remember that how you're filling in your brackets is you're taking your common factor and dividing each term by this common factor 4x, and that gives you what's left over and remaining. So if you divide 8 by 4, it gives you 2, and then x cubed divided by x is x squared. Remember, you subtract your exponent, so 3 minus 1 is 2. Okay, negative 20 divided by 4 is negative 5, and x divided by x is nothing, so you just leave it without just a negative 5 by itself as a constant, no variable with it. Okay, so to get that, did you get the same result as here? Yes, we did. Okay, so therefore 4x 2x squared minus 5 is equal to 8x cubed minus 20x is what you're looking for there. Okay, so show your work if you have a question like this, but that's just getting you into thinking about common factoring. Okay, and just make sure that you are somewhat showing your work for these, so that I can see how you came up with it. So show your work for common factoring. You don't have to write out all these factors unless you need to for some of the more tricky numbers. Okay. So next question, looks a little bit more complicated. We're just going to expand and simplify this, okay? So main thing here is going to be to use distributive property because you see that you have a monomial times a trinomial, okay? This negative is even a monomial because it's like a -1. We're going to times it by the trinomial, and then we just have addition. So we're going to use distributive property first, okay? So use distributive property first, and then you're going to collect like terms. Okay, that's how you simplify. So expanding is distributive property, simplifying is collecting like terms. Okay, so when you're doing this, I'm going to draw, I like to draw the arrows because that means I remember to multiply into all of my terms. Okay, you can go under 2 if you run out of room. Okay, this 7x to the exponent 5 does not get multiplied by any of these monomials because it's by itself. It doesn't have any brackets followed by it, so just leave it as a term by itself at the end. Okay, remember your equal signs as you go down, and you're going to be multiplying. Remember to multiply with distributive property, okay? So 3 times 4 is 12, x squared times x5, sorry, x3 is x5 because you add your exponents, so x2 plus 3 is 5. 3 times negative 2 is negative 6, x squared times x squared is x to the 4, 3 times 6 is 18, x squared times x is x cubed. You can drop brackets now that you have multiplied through with distributive property, okay? And this is just going to become one really long equation, okay? Now, negative 1 times negative x to the 5, so you're just switching your signs on all of these, negative 1, so this becomes negative x to the 4, negative 1, negative times a negative is a positive, be careful there, okay? And then you have your lonely 7x to the 5 at the end there, okay? Now, what you can do is just go through, and you can use different colors or different lines or whatever, but I would go through and underline all of your common terms. Remember, what makes it a common or a like term is that it has the exact same exponent on it, okay? So you have 12x to the 5, you have a negative x to the 5, and we have the 7x to the 5 here, okay? Then you have your negative 6x to the 4, negative 5x to the 4, and let's go yellow. Here we have 18x cubed and positive x cubed. Okay, so what you can do is you can go through and you can write all three of those terms together so that it makes your addition or subtraction a little bit easier. Okay, make sure you carry the sign out front of it with the term as you move it though. Okay, so there's your 3x to the 5 terms. Then let's do your negative 6x to the 4 minus 5x to the 4. So do your x4 terms. It's just nicest to write the terms lowest, highest to lowest as well when you're doing this. And then yellow, so plus 18x cubed plus 4x cubed, which means start with the 5s and end with the 3s, okay? So then when you're doing that, you're simply adding and subtracting now. That's what you do for adding and subtract for common terms, for collecting like terms, okay? I meant to do this color, okay? So you're just going to go 12 minus 1 is 11. 11 plus 7 is 18, x to the 5, okay? Then you're going to do negative 6x to the 4 minus 5x to the 4 is negative 11x to the 4. And then for our yellow, 18 plus 4 is 22, and then x to the cube. Notice how my, I'll do a star here, so when you are collecting like terms, your exponents on your powers do not change. So I don't go 5 plus 5 plus 5 is 15 or anything. It stays as 5 because we are just collecting like terms. We are not multiplying. Remember, only multiplication of x times 5 times x times 5 times x to the exponent 5. Only that is what changes your exponents, okay? So remember to leave, when you're collecting like terms, remember to leave your exponents alone. Okay, remember to leave those exponents alone. Okay, so that is your final answer there. So that is what you would write for me there. Just make sure that you are being neat about it. Your equal signs line up for it, and it's easier, I find, if you color code, or you could use like a double underline and a triple underline as well if you don't have colors. Okay, so on to our next example. Another word problem again that we're going to have to use some distributive property once we come up with some equations. Okay, so sporting good companies provide skis and snowboards to instructors at ski resorts. Determine an expression that represents the combined value of the equipment after Y years of use. So we have skis and snowboards. So we have information about skis and information about snowboards, but we want to combine that. Okay, so that's where you're going to get that distributive property. Use this value to determine the combined value of all equipments after 2 years of use. So part 1 is determining that expression, and then part 2 will be using the value to determine the combined value. So if you remember back to previous grades, we are just looking at a linear function because you're given an original value, and then after a certain number of years, it's going to drop in value by $50 depending on how many years it is. So using y equals mx plus b, you are able to determine your original value. Okay, and then your drop in value would be like it's your slope. Okay, so don't worry about number provided yet, because that when we actually combined our equipment, that is what when we'll use that. Okay, but so for coming up with your skis, you have this would be like saying y equals mx plus b. So they're using a y here. It doesn't. I would have put an x there. That's fine. They have just reversed this equation. So it's fine if you put negative 50 x plus 600. That is fine. Just make sure you have that negative because it's a drop in value, which makes it a negative. Okay, either way, we would get the exact same answers. For for snowboards, same thing. You could have had y equals negative 60x plus 800. That is totally fine as well. Okay, so if you use this way, whatever makes sense, or this way versus these two, that's fine. It's up to you how you use it. It's just essentially it's the terms b and mx are totally flipped, which is totally fine. Okay, then when you're plugging into your equation, oh, it's because they did y years of use here. That's why they have a y here. It doesn't really matter. Okay, but then you're going to get your value here, and then because they told us that the number provided is 200 for skis, we're going to put a 200 out front. And then because they told us the number of snowboards is 300, we're going to put a number, the number 300 out front of our equation. Okay. Then you're going to distribute this. We're adding them together because we want it to represent the combined value of them. Okay. Sorry, that's a terrible line. So when you are going to solve this equation, you're going to use distributive property. Okay, so 200 times 600 is 120,000 minus 200 times 50, so 10,000, and then you just have a y. Same thing here, 300 times 800 and 300 times negative 60y. Then combined, so you're going to collect like terms here. So 120,000 plus 240,000 is 360,000, and then negative 10,000 y minus 18,000 y is negative 28,000. Okay, so again, here's an example. I didn't change colors. I just underlined common terms. Here's your constants, and then here's your y variables with just a y to the exponent 1, so you're able to collect them because they're like terms. Okay, so this is your equation. So this is number 1 completed. That is your combined value of those ski and snowboards. Okay, and then to get after 2 years of use, you're simply going to plug in y is equal to 2 for that equation. 360,000 minus 56,000, so 304,000. So after 2 years, the combined value is 304,000. Okay, so that is an example where you have to come up with equations. I hope you can kind of remember y equals mx plus b for that in case you see it in your homework. But remember, it's just your slope and your original value. So original value, and then this is your slope here. Okay, so that's an example of where you would have to use distributive property as well. Okay. That is it for our first lesson. So again, main concept here is distributive property. We'll see that in your homework. Just let me know if you have any questions. Your homework's on page 112, 1, 3, 4, 6, 9, and 11. Okay, good luck.